Hello, I hope everybody had a wonderful lunch. You are about to be wowed by somebody who largely needs no introduction, Rick Houlihan, who is MongoDB's field CTO. Prior to coming to MongoDB, he was at AWS, where most recently he had been the worldwide technical leader of NoSQL services. And now I would like to welcome him to the stage. So thank you so much. Give him a round of applause.
Thank you. Hey everybody, thanks so much for taking your time out of your day to come join us here at MongoDB Local New York. Very happy to be here and really pleased that you're here to listen to me talk about a technology that I'm very passionate about, which is NoSQL, specifically document database technology, MongoDB. As Krista mentioned, I was the formerly, this is actually my second tour here at MongoDB. I was spent about 10 years at AWS in between stints here, and I was the worldwide technical leader for NoSQL services at AWS. I ran the black belt team for NoSQL technology for Amazon Retail. And some of you may be familiar with the relational to NoSQL migration that company made. That was my team that actually led the design patterns and best practices development, for that effort. And that's a little bit about what I'm here to talk to you today. Actually about, and is why NoSQL? Why does an organization, an enterprise like Amazon make a decision to choose a new technology over a traditional tried and true technology like the relational database, right? The thing that developers know so well, why would we move away from this? And there were some really good reasons for that. As a matter of fact, the original mission when we started this project we called Rolling Stone was not to replace the relational database. It was to replace Oracle, right? Oracle was very expensive, and it was very embarrassing for Amazon leadership to get up on stage at reInvent every year and talk about this wonderful, database services that we have, and then a week later, here's Larry up on stage at Oracle World saying, well, if your stuff's so great, then why are you my largest customer, right? So the mission originally wasn't replace the relational database. So we'll talk a little bit about how it became that, right? Then we're going to talk about what does it mean? What were the decision factors that went into finding that path, so to speak, to database freedom, and what were the things that we considered in doing that, and how do we make it work, right? And what it comes down to make it work is modeling relationships. Funny enough, all the data we work with today is relational. It's not non-relational. There's no such thing as non-relational data. Non-relational data is the static on the airways between the radio channels. It's the data on the hard drive before it's formatted, right? It's the stuff we don't care about. If we are querying the data, it's relational and it matters, those relationships matter. And how to model those relationships are going to drive whether or not that database is going to work for you or not, whether we can do that efficiently. Then, once we've figured that out, how do we execute that plan, right? How do we get 25,000 global developers to start thinking in a new way, to march to the beat of a new drum? And what does it mean to manage a technology transformation at enterprise scale? Because that's what it came down to, that's what we were doing. All right, so the first thing we'll talk about is this great migration. By the way, the timer's not working. Can we get the timer to start counting down? There we go. So it's this great migration, right? How do we get off of, how do we get to the NoSQL technology? How do we get our developers to kind of work that way? And why do we even care about that? So again, Amazon was not born in the cloud. Contrary to popular belief, many people think that Amazon was a company that was born in the cloud, so it must have been easy for you to move to NoSQL, right? That's not true. Amazon was born in 1995. It was built on monolithic services. Before service-oriented architecture even became a standard within the company, we were already a $5 billion business. So you can imagine there was a lot of legacy technology in there, a lot of legacy IT stacks, big monolithic applications, and we really need to get off of those platforms. Again, the mission that we started with this project we called Rolling Stone was to replace the Oracle databases for the reason that I talked about. We were the largest Oracle license in the world. We had the biggest Oracle rack deployments in the world. And by 2018, scale was breaking a lot of things, right? And a lot of it was what Dave talks about in his keynote. We talk about the friction of working with data, right? The friction of working with data in the relational database platform is very high, okay? And it was slowing us down, right? Again, with 3,000 Oracle Server instances, 10,000 application services deployed on those instances, and any change to any one of those services was potentially impacting others, right? So there's a lot of cross-contamination in the environment, and really the development organization was just moving slow. But what started to become apparent to us when we started to actually break down those 10,000 services and look at all these workloads was that the cost of the relational database was really a big line item. As a matter of fact, it was the biggest line item in our IT budget, right? The infrastructure associated with the relational database and the cost of the relational database was our largest line item. And one thing that Werner and team noted, right, Werner's office of the CTO was the one that was actually investigating a lot of this, and what they found was that the NoSQL database that was actually driving a lot more efficiency for the services that chose to go there over the relational database. And this was really interesting because he's like, why is that happening? Why is it so much more efficient for us to run the same workload on a NoSQL backend than it is for the relational database? And what it came down to is maybe there's a better way, all right? And it's not new thinking. Okay, we're going to hear this a lot today. It's not new thinking. The reality is that history repeats itself because nobody was listening the first time, and that is the case with the relational database today. If you look at the timeline of database technology, it's about what I call a series of peaks and valleys in data pressure. Right, data pressure is the ability of the system to process the amount of data that I'm asking it to process in a reasonable cost or a reasonable time. When one of those dimensions is broken, that's a technology trigger, and we're going to start inventing things, and we've invented many things over the years, okay? The first database was a great database. It's the one between our ears. We're all born with it. Highly available, right? When my eyes are open, it's online. Yeah, questionable durability, zero fault tolerance. We're not going to build an enterprise service on a single user system, so we started to develop something else, right, to store structured data, and that was ledger accounting. We started writing things down, okay? We started storing structured data by writing it down on paper. And this ran public and private sector services for millennia, many millennia, until the 1880 US Census, and Herman Hollerith was tasked with processing all of that data. It took him 8 years of that 10-year cycle, and he needed to invent something for the next round. He invented the machine-readable punch card and the punch card sorting machine. And a small little company called IBM was actually born off of that technology. The long and storied footprint on the database technology space. Rapidly, we invented many things: paper tape, magnetic tape, distributed block storage, random access file systems, hierarchical management systems. The message here is that there were many things that existed before the relational database, and they worked fine for a while. Okay, in 1980, we came across the relational database. Wonderful system. It's driven our application development for the past 50 years almost. But the reality is that Edgar Cott himself knew that there were limitations to the systems, and many of those people who critiqued the relational database at the time did so because of the cost of the CPU, right? The relational database was invented because, and Edgar Cott wrote this in his famous paper, future users of large shared data banks will need to be able to ask questions of their data without having to write code. And that was really the mission, right? This is why the normalized data model was born, so people could write queries without understanding in detail how that data was stored, so they didn't have to actually write complex code to do it. But the cost of the relational database was always recognized. Again, the critics of the day realized that CPU join was expensive. And they always said, you know what, that's great for OLAP workloads, but it's not going to work for 90% of those workloads out there, the OLTP workloads, the transactional workloads, the ones that run at high velocity, right? Well, Moore's Law was the friend of the relational database. It powered the relational database because the relational database relies on cheap CPU to drive efficient solutions, okay? Fast forward 30, 40 years and we're in a different situation. Okay, for the last decade or so, Moore's Law has actually been broken. And what we're seeing now is that a database like a NoSQL database that relies on an efficient data model to reduce the CPU load is actually going to drive infrastructure efficiency much, much better, okay? So again, this is just reality, right? Moore's Law is no longer an enabler for the relational database. If you look at this chart on the top left-hand side there, that's the top 500 supercomputing clusters around the world today. And now these guys invest in every single technology that they can to get as many petaflops, zettaflops, whatever they're calling it today, as you possibly can squeeze. But they haven't been able to hit Moore's Law for a decade now, okay? Why? Why? Because CPU performance, per thread performance is flattening out. Cost per core has been increasing since we got below 28 nanometer. At 7 nanometer, that's about as far as the server processing space is going to go. 5 nanometer CPU doesn't even exist yet in Intel space. In AMD, they announced it, and now they also recently announced that they're reducing 5 nanometer wafer inventory indefinitely because of the cost. The 3 nanometer disk is going to be over $30,000 per single wafer. Okay, so gate cost is going through the roof. CPU efficiency is dropping as a result. The only place we're seeing 5 nanometer CPU in mass is mobile devices, right? We all have one of these, and there's 5 years of subscription services associated with every sale, so you can sell that CPU as a loss, right? We can't do that in the server processing space. However, the cost of storage continues to fall, right? We're just seeing storage gets cheaper and cheaper and cheaper while the CPU actually gets more and more expensive, right? Cost per 100 million gates, right? The physics are undeniable, and it's not new thinking, okay? Again, not new thinking. This is Edgar Cott himself in his paper, Large Relational Model of Data for Large Shared Data Banks. He talks about the efficiency of normalization in storage, the deduplication on disk, the efficiency of normalization in communication of bulk data between systems. But he also talks about the efficiency of denormalization, right? If you actually introduce strong redundancies into the stored set, we can start to see increases in efficiency in CPU for certain queries, okay? This is a key, because when you model data in NoSQL, what I want to do is I want to drive efficiency for your high velocity queries, right? The things that are running 100 times a second, 1,000 times a second. That's where I care about the cost, okay? The thing that runs once a day, once a week, I really don't care how expensive that query is, right? What I want to do is I want to maximize efficiency where it matters, and that is the mantra of NoSQL, right? So the man himself is telling us this. He's also telling us about the cost of normalization in that lower left on defining the ERD, where he talks about don't join in the immutable data, right? Don't create these tables with these events that have info, warning, and error, and then write a join to get those labels, right? Those labels are immutable. Just tag those rows, tag those event rows with the immutable data. Why? Because it's okay to denormalize, right? To increase the efficiency of the system and avoid the cost. Now we've kind of gotten away from that today because over the years, the CPU efficiency has increased so much that we just don't think about it. But again, when Werner and team were breaking things down across 10,000 services at Amazon, it became very apparent that there was a huge cost efficiency discrepancy between the NoSQL workloads and the relational database. So let's talk about when, right? When NoSQL, when SQL. And this is a question that's actually pretty gray zone these days because databases like MongoDB, right? We have SQL read APIs off the back of Atlas. So the fact is we can run those OLAP workloads, but if we break it down, the relational database is actually pretty good when you have ad hoc queries. When I don't know what the query is going to be, the relational database is probably the most efficient way to support that query. The reality is those OLAP queries, they don't run at high velocity, right? They're not latency sensitive. The help desk tech that's drilling through the event log to try and figure out what happened, he's not going to know that the query came back in 100 milliseconds versus 10 milliseconds. He doesn't care, and neither do you, because the cost of those queries is pretty low compared to the cost of those transactional queries that are running high velocity all the time, right? And that's where NoSQL is really going to shine. NoSQL is built for OLTP at scale. We're going to optimize that data model for those high velocity queries, and in so doing, we're going to allow you to save a lot of money. And we scale infinitely using this model, right? All NoSQL databases actually scale exactly the same way as MongoDB through sharding of the key space. The reality is, it's not NoSQL, it's not only SQL, right? We actually support that SQL read API today off the back of that MongoDB Atlas, so you can support those OLAP workloads off of your operational data. There's a lot of efficiency in this system, and this is really one of the reasons why I'm here at MongoDB today, right? This developer data platform, this thing that allows us to satisfy the workloads that developers need to support using one tool, not 10, right? We don't want to actually spend a lot of time understanding how to glue ETL together between different data sets. We don't want to have to worry about consistency of data sets, right, across different stores. I want to run my workload. I want to learn one API, not 10. And this is really one of the things that NoSQL databases like MongoDB today give you the ability to support that. All right, so making it all work, right? I like this quote because it makes me think that maybe Mark Twain was a time traveler, right? Data's like garbage, you better know what to do with it before you collect it, right? I mean, no more, there's never been more truth in that statement than today. Mark Twain was actually an early investor in storage technology. He invested in the linotype, which was rapidly made obsolete by the machine-readable punch card and the punch card sorting machine. Regardless, these charts are a little out of order. The bottom line is, it's all about relationships when we build applications, when we use data. I need to be able to express those relationships efficiently in the database in order to be able to use the database cost effectively. And it doesn't matter what application I'm building, social networking, document management, IT systems monitoring, anything that I'm building that I'm using data, it has relationships in the data. But the reality is it's access patterns that drive cost, okay? When we were at Amazon working on this project, 2017, 2018, Werner's team broke everything down and they found across 10,000 application services at Amazon deployed across those 3,000 relational database instances, 70% of the access patterns accessed a single row of data on a single table. Okay, 20% more accessed a range of rows on a single table. And you look at that and go, well, that doesn't make any sense, but the reality is it actually does, because OLTP applications are extremely write heavy. Okay, a lot of times that data gets written and never read. Okay, it's just write. User logs into the portal, maybe they'll query for all that data relationally, but the reality is the last 10%, that small number of queries, the ones that said join, they required 50% of the infrastructure that was deployed to support the last 10% of access patterns, because joins are expensive, all right? So if we break it down, we can see why. When we look at our standard relational model here, this is a product catalog example. If we were to look at how we would store product catalog data in a relational database, we might break things down in these tables. We'd have a products table, we'd have different types of products, we'd have a one-to-one join between those tables, one-to-many between albums and tracks in this example, many-to-many between videos and actors. And if we think about how the system accesses the data, it kind of wants all the data all the time for a given product, right? What am I doing? I'm selecting products by category, products by type, maybe sorted by price or filtered on some particular property, but I always want the product. I don't ever want the actor row, right? I want the product. So it's a key value type of access pattern that we're dealing with here, maybe range queries on secondary attributes. But the reality is the product data should come to me as an object. And so what are we going to do as developers? I'm going to put a cache in front of this database. Why? Because intuitively I already know the database is expensive. Joining those tables to produce a product every time I need is expensive. So let's put a cache in front of the database so I don't have to do that. Now what have I done? I've increased the complexity. I've added ETL plumbing between my database and my front end, my cache that I'm actually driving my application off of. It's just additional overhead on the developer to be able to now deal with cache coherency, cache consistency, and that ETL between those two systems. Why? Why do you want to do that? Maybe I should just use a database that stores the data the way the application actually uses it. There's a document database. In this particular example, it's perfect. It's a key value type of access pattern. Like I said, maybe we'll see some range queries on secondary attributes, but I always kind of want the product. So I'm going to create product objects, documents. I'm going to store these things in the database, and I'm going to index that collection of products to be able to pull back my list of products. And it's intuitive right now. If I want to get a full list of products, I just have to do a collection scan. I get all my products. If I want to get a list of products with the relational database, I've got to go and query 3 different queries of various levels of complexity. And as a matter of fact, let's break those queries down and see what that time complexity looks like. Because as developers, this is really the most important thing for us, is the time complexity of what we're producing, right? We always talk about time complexity. I love it how developer teams, they'll break down their code, they'll talk about the time complexity, and then we'll hand off to the relational database. The relational database is the biggest freaking time soak of anything that you could ever hand off to, right? We want to know what the data is doing. You don't really know what the relational database is doing. It's shoving data all over the place. It's an abstraction layer between your application and the actual data storage. It rips your objects apart, it shoves those objects into rows on those tables, and then it reassembles them whenever I need that. That's a hell of a lot of overhead that we're going through. And that actually translates into this time complexity. Let's look at that one-to-one join. It's not too bad. Right, and again, all these queries that I'm showing you, they're all going to reduce to O-log-N, but there's a lot of extra CPU cycles you just can't ignore, right? The reduction, all that stuff that was reduced, right, and there's plenty of SQL queries that go beyond an O-log-N time complexity. As you can see, this stuff is simple queries, right? We get into that join through the one-to-one into the one-to-many, it just starts extending more as we get into the many-to-many, and for the DBAs in the room, you can look at this query and say, well, yeah, but when was the last time you saw anything that simple, right? I mean, the stuff I see in production is pages long with outer and inner SQL and derived tables and joins on derived, all kinds of crazy things. You can see that time complexity just explodes, okay? Now let's go back into a NoSQL environment. We're going to talk about, first we'll talk about the key value access pattern, but then we're going to talk about a little more than that, because applications have more usually more access patterns than key value. But the key value lookups are always going to be really fast, right? Because essentially we have a single document that describes a product. I'm going to go get that document, it's O-log-N. Let's talk about how these documents are structured here. So I have a modeling convention I've developed over the years, where essentially we're going to have a unique identifier that in MongoDB, that's the underbar ID. In DynamoDB, that would be the partition key. So there's some kind of unique identifier for this document. There's some sort of type attribute that tells me what type of document this is, because in NoSQL databases, I can put many types of documents in one collection. Essentially, that's how we get efficient. We'll show you that in a second. But the type attribute tells me what the document is. The data is a sub-document. This is what I'm looking for, right? When I go look up this document, I'm trying to get the data, right? Every document's going to have a little bit different data. Every type of document will have a little bit different data. But what's really going to be interesting here in a second is this target array. What you're seeing there is an array of pointers to other documents in the collection that I'm related to. So this document is actually related to itself. It's related to its author, it's related to its publisher, it could be related to many, many different things, okay? But again, it's a key value lookup to get the document for the book, it's O-log-N. Key value lookup to get the document for the album, it's O-log-N. It's got some different targets, right? The target is to the songs that it's related to, it might be to the musicians that performed it, the studio that produced it, so on and so forth, the engineer that recorded it. Again, anything that you want to associate to this document, you can throw into that target array. Same thing for the movie now, right? We're going to have target array pointing to the actors, to the directors, to the maybe cast and crew, right? Whoever is associated to this document. And again, if I do the key value lookup on the movie document, it's O-log-N, I get the movie data, I get some information about the actors and the roles they played. But what's more interesting is when we want to actually have more complex queries, right? So applications, again, they have more complex queries than key value access patterns or simple range queries. We might want to do things like get me all the books that an author wrote. Get me all the books, or get me all the songs or albums that had a song on it, or all the artists that performed the song, or all the roles that an actor has played, or all the movies they've been in. Or give me everything that's associated to this movie, and I want all the data. I don't just want these pointers, I want the data. Okay, so how are we going to do that? Well, if we index the target array, one of the interesting things about the relational database, if you think what the relational database does at its core, it joins indexes across tables. What does a join? A join is a merge sort. All right, it's merge sorting on a common attribute, right? This is what we're doing. So if I actually take that index and I put all those rows in one table and I draw an index across those shared attributes, I don't have to join the index anymore. It's already joined, it's pre-joined. This is the idea with NoSQL. I'm going to embed data into documents and I'm going to pre-join the indexes in a common collection to reduce the need to actually execute joins. This is how we're going to drive efficiency in a NoSQL database like MongoDB. So now let's get anything that's related to Mary Shelley. Give me all the books she wrote. Give me all the people that she's related to. Get me all the, everything that's related to a given song or everything that's related to a given actor, right? Actors might be directors, producers. I could say, filter on type, get me all the roles that they've had, get me all the movies that they produced, so on and so forth. As we get into the musicians, same thing. But the big one, this many-to-many join, right? Look at the time complexity. It's O-log-N because it's just an index lookup. And in this particular example, I could have thousands of documents associated to this movie, right? Every member of cast and crew for this movie could be pulled back on an index lookup with O-log-N time complexity. So you can clearly see how we're removing those extra CPU cycles that are associated with those joins to be able to produce these types of queries that are very, very high performance. Now, it's never been hammered home more than it was on our earnings call just a couple of weeks ago when Dave got out there and told the world about Temenos. You may have heard about them, global financial services company. They were running, I think their back-end database was a combination of Yugabyte and MongoDB. They noticed the efficiency of the MongoDB backend. They moved all of the access patterns over to MongoDB. They cut their infrastructure in half to support their workload. 150,000 transactions per second, and they're running now on half the infrastructure. Why? Because they eliminated the joins, right? Get rid of those joins, you'll cut your infrastructure in orders of magnitude, right? I talked to teams today, not today, been about a year since I talked to these teams at AWS, but I used to get every couple of months, I would get a team that I worked with during the Rolling Stone project pinging me and letting me know how it was going. And it was always around we've been growing for 3 years and we're just now spending as much money on our database infrastructure as we were in 2017. We've been growing for 4 years and we're just now spending as much money. This is no joke. right? The biggest IT expense in the enterprise today is database infrastructure. If we can reduce the time complexity of the queries that we're executing, we can reduce the cost of our database infrastructure, and we can move the needle when it comes to TCO, right? We do it all the time. This is exactly what my team does. And this is what it comes down to, is executing the plan, right? One of the things that we found over the years, I found at Amazon, was that teams don't know how to model their data for NoSQL. Right? They know how to model their data for the relational database. That's what everybody knows, okay? Is there any DBAs in the audience today? Okay, tell me how many developers that you've ever met that actually know how to use the relational database. Zero, exactly. Developers know how to hack on the relational database. They can get going really fast because they understand the normalized model. They don't know how to write queries. They don't know how to index tables. They don't know how to effectively use foreign keys, right? Developers have a tough time actually understanding how to work with data. Why? Because it's freaking hard, all right? The relational database is really hard, but we spend a lot of time working with application layer objects. We build those objects, and we know how to make those efficient. We build object structures that mirror the way the application uses the data. So maybe I should use an application, a database that does that too. And that's the key thing here in this chart. If you look at the bottom of this chart, this is the technology adoption curve, right? As you look at any ecosystem, when I inject some new technology, you're going to start off on the left-hand side, right? There's going to be the early adopters, the innovators. They're going to have a problem. They're going to use a new technology. They're going to have a good result. Other people will see this. They'll go, hey, this is wonderful. Let's go use it. But then what happens is the hype curve up above, right? Again, something new was invented. It solved the problem. Somebody else with that problem goes to try to use the new technology, and what do? They try to use it exactly the same way that they use the old technology, and they have a miserable result. And this is exactly what I see with NoSQL database today, right? Everybody wants to use it, but they don't know how. They start to use it. They use it like a relational database. It doesn't work that way. They have a bad experience. They say, that's not for my data. Okay, but the reality is actually once we understand how to use that technology, right, when the early majority arrives and everyone knows how to use it, we have a better experience. Everyone goes, oh, okay, now I get it. And so if you look at the relational database today, we're all the way on the right-hand side. If you don't know how it works, you're kind of a laggard. Like I said, most developers don't really know how it works, but they know how to get going, okay? The reality is in the NoSQL database technology today, we're still firmly in the early adopters chunk. I think we're past the chasm, so to speak, because we have market leaders like MongoDB out there now, have established ourselves as the go-to technology in the space. But there's still a lot of misinformation and a lack of understanding of how to use the technology, right? So that's really what my team does. We're about actually enabling customers to use the technology to be able to make better decisions. I don't like selling anything. I told MongoDB when I came back, I'm not going to sell anything. What I do is enable teams. Developers are really good at figuring out how to use an SDK, right? They know how to go online and get whatever information they need out of Stack Exchange or ChatGPT or whatever they need to get the information that they want to get. But where they break down is modeling the data. And actually, if you follow me on Twitter, you'll know that ChatGPT breaks down on that too. Why? Because it's an inductive process, right? It takes a little bit of insight to understand how to apply the design patterns correctly to make things work, right? So that's what my team does. We work with teams. Essentially, what we found at Amazon was that the standard DevRel playbook, it doesn't work very well with NoSQL technology because there's no lowest common denominator, right? What we really want to be able to do is teach developers how to solve the problem they're working on. Because solving a problem in a workshop or in a hackathon or listening to me talk, that's great. I can teach you how to solve a problem, but it might not be your problem. And NoSQL databases are so tied to the access pattern that it really needs to be about your problem. So we kind of flipped the script. We developed a new playbook for DevRel for NoSQL at AWS. Essentially what we do is we come in, we have these things we call MongoDB days. We'll show up, we'll talk about the technology like this, we'll have all kinds of breakout sessions, but then the real meat is instead of workshops and hackathons, we do design reviews where we sit down with teams and we understand a little bit about what they're trying to do. These are typically 1-hour conversations where we can give them a little bit of a hint. Essentially, we leave them with a prototype of a data model that they can actually iterate on. What I'm looking for in these engagements is what I call the light bulb moment. Right? It's when a developer around the room, around the table goes, oh my gosh, I never thought about it that way. I get that all the time, and as soon as I get it, I know I'm never talking to that team again. Or if I am, it's actually going to be a really cool conversation because they're going to come back to me with something really cool that they did, and this is how I've learned everything I know about NoSQL technology today, is from the people that I've worked with, because you guys all know your data better than I do. I can give you some breadcrumbs, I can give you a hint or two, but when you go down the path and you actually iterate on that model, you're going to come back to me with some really cool things. Now, it doesn't happen as often as it did back in the day when I was doing the Rolling Stone project, but it still happens. I had a team the other day, just a couple months ago, come to me with a variation on one of our core design patterns that I thought, wow, that's really cool, and I put it in my book, and I've used it once or twice since then talking to other customers. So again, you guys are my best resource to help expand my knowledge, and hopefully I help you guys expand yours as well. And the best way to hammer that home is by example. So one of the teams that I talked to early on at Amazon was the shopping cart service, right? We all use the shopping cart at Amazon, right? How many people use the shopping cart at Amazon, all right? How many people actually add items to the shopping cart that they don't use, that later on they remove? Hey, I do it all the time, right? So if you think about it, you're kind of using that shopping cart like a database. I'm adding items into it, I'm removing items out of it, right? The items in the shopping cart, they actually have their own life cycle. They get updated independently of each other, right? Which actually makes sense, because as we found out, when Werner broke things down, 90% of the access patterns do what? They access a single table. You know, one row, 70%, 20%, multiple rows, but they work with data in bits and pieces, okay? Same thing with the shopping cart, okay? So the shopping cart team went out and they created an item on the DynamoDB table. Partition key was the shopping cart ID, and inside the item they had some metadata about the shopping cart. Then they had an array of sub-documents that they were posting in there, one document for each item, okay? So that was great, but when you think about, like I said, I mean, I don't know about you guys, but I can end up with 8 or 10 items in that shopping cart. When I go check out, I only want 2 or 3 of them. I'm like delete, 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 move to wish list, all that stuff, right? If you think about it, every time you add an item to the cart in DynamoDB, it's about a kilobyte of data that they're putting into the item. That happens to be about 1 write capacity unit. So they'd add one item, it was 1 WCU. They add the second item, guess what? I had to read the first item to write the second item, so now it's 2 WCUs to write it back. Third item is 3 WCUs. You remove the third item, it's 3 WCUs, right? So as you get the idea here, it's getting more and more expensive the more items they add to the table. And again, because the vast majority of users actually keep items in their cart that they're not buying, that meant that almost every single item that got added to the table was really expensive, 2 or 3 times more expensive than it was in the relational database. Because in the relational database, they had a shopping cart table, they had a shopping cart items table, and they actually added items and removed items from the shopping cart items table, so they were moving little chunks of data. So what was the solution? The solution was to create essentially an index in DynamoDB. You have the ability to create a partition key and a sort key. This more or less creates an index of items on the table, and we would have a partition key was the shopping cart ID, the sort key was the ASIN, the metadata item had a sort key of 0, and now all of a sudden I could select the whole shopping cart, or select where shopping cart ID equals X, it brings back all the items in the cart and the metadata item, but I could add items and remove items to the cart without having to touch the other items, so all of a sudden we dropped the cost of that data model down significantly, and then the team was able to actually use DynamoDB and save money. And so a good example of how learning how to model the data can drive cost, right? And so a lot of people who think that NoSQL won't work for me, what it comes down to is you're working with an inefficient data model. If you're working with an inefficient data model, no database is going to work for you, right? So let's learn how to optimize that, and we're going to have a better experience. That's what we're all about, right? We want to get people over that hump. We want to get people to the point where we're on that slope of enlightenment, because you are empowered once you know how to do it, right? You're empowered to make better decisions. One of the things that I like to share is that my team, we do a lot of design reviews, right? So far this year, we're almost 200 design reviews on our fiscal year. It started at the beginning of February, okay? We have a 90% new workload conversion rate. We don't sell anything. All I do is teach developers how it works. They come back and tell us, yeah, we're going to choose MongoDB, right? If 90% of the developers we talk to are coming back and saying, yeah, I want to use this database, that's actually a pretty good indicator it's a decent technology, right? And that's really what it's about. Dive deep on this technology if you want to know how it works. And we can do that at what we call our MongoDB days, where this year we're actually opening these things up to open developer days across, we're actually running design reviews here at MongoDB Local today. If you're interested, I think we've still got a couple of slots available this afternoon. If you don't have time today, we also run these design reviews ad hoc. So feel free to reach out to your account rep. They can give you a QR code you could scan and set up a design review with somebody on the developer relations team to go through your data model. And really that's what it's about. It's about an exploration of NoSQL data modeling. How does this work for you? We'll give you some breakout content like this, maybe even deeper in aggregation framework or API feature functions, whatnot, developer data platform. But the real meat of it is these whiteboard sessions, right, with subject matter experts. We want you talking to our data modelers. We want to empower you to be able to make good decisions, and to do that, you got to know how to use technology. So again, reach out to your account rep if you have any questions about any of that stuff. If you have anything you can take out of today's session, right, please understand NoSQL is not about non-relational data. I don't know what that is. I've been working with NoSQL technology for almost 2 decades now, and I still have yet to find it. Like I said, it's the dust between the stars. It's the things we don't care about. The ERD still matters. It's the core of the logical data model, is everything about how we're going to actually structure the data. It's the access patterns against those entities that are going to drive your document structures, and really understand more than anything, the relational database is a fantastic technology. It's been around for almost 50 years. Nothing lasts forever. The relational database efficiency is declining today. Like every other data storage technology that we've invented throughout history, it's had its time and place, but the efficiency of that relational database is declining today, and you just can't get away from it, right? It's built on, the relational database requires cheap CPU, efficient CPU to drive cost-efficient solutions, all right? The reality is that the NoSQL database reduces the load on the CPU by driving efficiency into the data model. There's one that's going to be a clear winner in today's market. I don't know if I need to tell you which one. NoSQL is really the best fit for OLTP, workloads at scale. That's where the sweet spot is. We support OLAP just as well. And again, one of the key messages to take out of this session today is that those OLAP workloads, they're not latency sensitive. They don't run at high velocity. Those are not the things that are driving your cost, right? If I abstract my SQL engine over the top of my denormalized data, it's going to be less efficient than the relational database. But from a business perspective, we just don't care, because that's not where we're spending the money, right? We're spending the money on those high velocity OLTP workloads, so let's optimize that stuff, because that's where the bang for the buck is. All right, again, design reviews, please feel free, reach out to your account rep. I got the best in the business on my team, right? Not just me. I got, I don't know, half a dozen guys on my team. They're the best data modelers that we have in the company. These are people like Daniel Kupal. We call him the doc father. He's the father of the document data model. If you go to MongoDB University, you'll see him all over the M320 course, right? These are the people you're going to get a hold of if you reach out for these design reviews. So please feel free to do that. That's what we're here for. Again, thanks so much, and hopefully this was a good session for you. If it was, it's a great QR code to scan and give me a great recommendation. And if you didn't like the session, there's another QR code over there you can scan. Anyways, thanks so much, people. Thanks, appreciate it.